What's going on, everyone? Just doing a quick sound check. Can everybody hear me okay? Just let me know in the chat. Okay, we'll get started in just a second. Let me just set everything up here. All right, one moment. Okay, let me make me a little bigger here. So welcome to the stream. I know we didn't have one last week. I apologize for that. There was a couple issues, one of which was my house was 100 degrees because my AC broke, and this is very bad to kind of get anything done. So I apologize for that. This will be a really good stream, so hopefully it'll make up for that. If you have any questions today, I want to put this out there before I start. I'm going to be doing a brief Q&A starting here in a little bit once I talk about a couple channel announcements, and then once I finish that up, I'm going to take some questions about like Python problem solving, and anything else you'd like to ask me. So if you would like to have your question answered live here, just go ahead and put it in the chat, and I will do my best to answer all of them. So for channel updates, we really only have two things to update. The first is that I'm coming up with a new segment. I thought that would be kind of cool. I don't know what it's going to be called. I don't know if it's going to be called like Fixed Your Code or GitHub Issue Warrior or something like that. But the basis of this segment is I'm going to take some fan submitted GitHub projects, possibly even your own, if you have some, and I'm going to find some simple issues and I'm going to fix them for you or do them. Maybe even if there's small features, I might do those as well. And hopefully what that will show is, hopefully that will give me this sort of huge pool of kind of discrete things that I can work on, and then people can kind of see the thought process. I thought about that as being kind of a cool segment when I was doing up this stream, in that problem solving is super important to programming, if not more important than the actual syntax piece. So I thought that'd be kind of a cool thing. So I'll post a specific email, an engineerman.org email at some point during the stream, for if you have any like discrete problems on one of your open source code bases and you'd like to submit them to me for me to possibly solve them in a video, then you can certainly send those over. I'll check them out. Let's see. Okay. The second thing is my new friends over at Adafruit. We've been chatting a little bit, and I'm going to be doing some tutorials featuring Adafruit equipment, things like CircuitPython as well as some other things. So I'm going to be getting that equipment here pretty soon, and then we'll be putting out some videos to help people sort of use that equipment, because of course their products are very popular and their stuff's very nice, and I'm sure a lot of people will get benefit out of using these particular products, learning how to do kind of like hardware type programming with Python, and that'd be kind of cool. They got some cool stuff. So that's going to be coming in the coming probably 2 to 3 weeks, maybe. I'll be putting out some stuff for that. So other than that, not a whole lot to update. We are approaching 250,000. I know I said I was making a 200,000 video. I have a lot of that content recorded. The problem is I'm having a hard time. It's not coming out the way I wanted it. I had this grand idea for sort of, engineer man kind of behind the curtain and, learning more about me than the tech. And I have recorded some of the content, but I'm having a hard time kind of putting it all together. So I'm reaching out to some people who can help me kind of bring that to a close. It's probably going to be more like a 250,000, video rather than the 200, since that's past 28,000 ago. So we'll definitely get back to that as time goes on. And that's it for the meta stuff. So I'm gonna jump into some Q&A, probably 5-10 minutes, and then we're going to solve one or two problems in Python. I don't know whether it'll be two. It just depends how much time we have. I have one that I think is harder than the other, and if I get through the hard one and I got a little time left, then we'll do the easy one as well. So that'll be cool. Let me check some questions here. What Python linter do you prefer for Flask applications? So I don't do any Flask programming, so I can't recommend a linter. But I know we do have a lot of Python Flask developers on Discord and probably some there in the stream today. So if for those folks who know of a good linter, certainly let us know in the comments what you think is best. Let's see. Kyle asks, what packages do you have installed for Atom? So I don't have that many. My Atom install is more or less default. I do have a couple things that I feel are extremely useful. The first is tabs to spaces. That's of course very important. And then I have the minimap, which lets me, I use it as just a giant scroll bar on the right side, but also gives me kind of like a glance at what the code looks like. JetBrains used to call it code glance. So for any of these JetBrains people, minimap is kind of the code glance for Atom. So I definitely use that. That's a good package. And then I also use, of course, all the highlighting. And then I use the variable highlighting, which means I can double click on a variable and it will show me all the instances of that variable in the editor. And that's really it. I don't use a whole lot besides that. The rest is just like language support and various things. Jerry said, will you be making a SQL video? Yes, absolutely. I do intend to do a pivot over to databases. It's a very important thing, and it's not a thing that I've done a whole lot of talking about on this channel for the last year and a half. So definitely expect some SQL videos in the future, because we really have no database videos. So that's coming. Antonio asks, will you be making a video about YouTube's API, getting messages from a live chat, maybe making your own YouTube bot in Python? I hadn't actually considered that until right this second. I'm not sure that there's even a YouTube bot. Maybe there is. I know we do have some YouTube integration on FelixBot. So if you are interested in how some of that works, you can go onto Discord and run the command Felix source. And then you can look up the Felix source code on there. And we do have some YouTube integration in there. I think it's under the stats cog. It's the thing where you run Felix stats, you get number of Discord members, number of YouTube views. So if you want kind of an example on how to do that, you can certainly find that there, at least in the interim. Will I make a full video about YouTube's API? Probably not, because I think that's too discrete of a thing. I like to cover sort of broad, widely available things. Arthur said Rails or Django. So I used to be a Ruby programmer for a little while, and I programmed exclusively in Rails, of course, because the majority of the people using Ruby in the kind of web sphere are using Rails. And as people do know about me, I am primarily a web developer. I do some system stuff and some general stuff, also some mobile. But my bread and butter, like what I see as my actual expertise, is of course in web, as well as web-like technologies, like desktop applications that are written using web technologies. So I got to pick Rails in that case. I've used both. I've never used Django on a major project, but I am familiar with it. I know what it is, and I know how it works, but I do like Rails better. Yoshi Bro said, I watched some talk about Python and they said Python 4 will never come because Python 3 is the best and there are only coming new packages from the community. I I don't see that as accurate. I mean, the only way that would be accurate is if Python somehow died, but there's always going to be an ask for an improved version of a language, and the whole purpose of going from like a 2 to a 3 or a 3 to a 4 is being able to break everything for the sake of making it better. That's why those exist. If they just want to add a new feature, they don't need to go from 3 to 4. They just go from 3 to 3.1 or 3 to 3.0.1. And so will a Python 4 ever come out? Yeah, I think it will, because I think Python has some huge staying power in the development world, and I'm sure we're going to get to a point where there's going to be new things that Python could handle better, or things that they want to fix, and they want to do so in kind of a backwards compatibility breaking way, in which case they'll have to increment that version to 4. So in short, yes, I think 4 will be here at some point. I mean, I can't think of a language that just did a 1.0, or I should say major language. I don't think I know of one major language that did like a 1.0 or a 2.0, and then that was sort of it. That just stayed there for 20 years. What's my educational background? I have a background in electrical engineering, and then was it worthy? So the thing about my background is I started out in software, and I went to college for electrical engineering, and then I kind of went back to software. So I never actually tied all that in, and I did that because I'm a self-taught software engineer, but I'm an educated electrical engineer. So it's sort of I was already really good at the software piece when I went to college, so I kind of did it in a unorthodox sort of way. So was it worthy to do that? I think it was, because it gave me a new look into a piece of technology that I previously didn't have, and that was very useful to me. Of course, if I just went for like a computer systems engineering degree, something like that, that would just be beating a dead horse. I don't feel like I would have learned anything additional there. I was already very passionate in the development space, and I always researched things that they would have taught in college anyways for a computer systems engineering degree. And because of that, I don't feel like I missed out on anything. But by excuse me, but by going for a completely different discipline, I learned a wide variety of new things that I had previously never seen. So that was very useful. Why use Python where you can use Godot or C? I So, I mean, Python has its use cases, and this is probably something that I'll just repeat here again. I say this a lot on the channel, and it's that the reason people have so many options for languages is because you have this big sliding scale of either really fast and really hard to write and really manual, and over here you have not as fast, but easier to write, and you can get things done quicker. So, it's fine to have options all the way through that sliding scale. On one end, of course, you have like assembly and then C. On the other end, you have Python, JavaScript, and Ruby. And sort of in the middle, you have these kind of languages that are sacrificing, tiny bits of speed for a little bit of developer happiness. That's I would lump like Go in that category. I'd put Rust in that category. Although Rust advertises zero cost abstractions, but you know, is it going to be better than what GCC can put out? I don't know. Tough to say. So, is it? It's not like you need to pick one or the other. They have things that they are really good at, you know, on their own. So you don't have to say, oh, I need to be a C purist or a Python purist. There's no need to do that. You can say, I'm going to use C when the project dictates that I should be using C, and I'm going to use Python when I need to get something done quickly, or I want to do some prototyping, or I want to make use of a library that's primarily written in, say, Python. So it's totally fine. Okay, so I want to jump into that was about 8 minutes, 10 minutes, so I want to jump into the actual bulk of this stream. Yeah, you can continue asking your questions. I'm going to answer all of them the best I can at the end of the stream. So let's jump in. So this stream is about, if you saw the title, then you're here to to watch me solve problems in Python. And I picked Python because, of course, Python's a very expressive language, and it is easy to sort of, oops, wrong one. Sorry, I'm getting confused here. Let's see, stream segment. Yeah. Okay. So if you're here, it's because, you want to, oh, I'm way too huge. I need to be less big. Gigantic engineer man. There we go. Okay, we're back at it. So there's sort of what I wanted to show people today is kind of my thought process when I go to solve a problem and how I arrive at a final solution to a problem. And what I'm going to teach you today is kind of, it could be applied to any problem, big or small. It's just, how do you break it down? So sort of the first step when I'm going to solve a problem is I want to think about the big picture. I want to kind of, if I could fast forward, 100 or 200 or 300 hours, or even a couple hours, however long it might take, if I could just fast forward to the end, what do I want that end result to be? What might it look like? And then I think about, is this product going to be visual or is it not visual? Of course, if it's just, data, then you don't have to worry about kind of what it looks like. You just have to worry about, I want this program to produce, X data. But if you're producing something that has kind of a visual output, then it makes sense to actually do a sketch. And this is something that people often ignore. People ignore the value of sketching out what you want something to be. So if I'm going to build like a user interface, or I'm going to build a something that produces some visual output, it makes sense to say, well, let me just stop and take a second and grab a whiteboard or a piece of paper or any number of online drawing tools. And you don't have to be an artist. It could just be circles and squares, but it really helps to visualize what the end state is going to be. And that actually applies to the problem we're solving today. Before we go any further, I want to let you know the problem that we're going to solve today. And the problem that we're solving today is we want to take an array, a list of integers, and then we want to graph those on a graph that is made in the terminal. So we're going to do terminal graphing. And that's the problem that we're going to be solving today. So right off the bat, that's a problem that we can visualize. We can imagine that if we were making a chart on the web, it would have an x-axis, have a y-axis. It would have some bars, it would have some colors, it would have some numbers, some labels, a legend for what it is. So we can already kind of imagine, what the end result would be. However, since we're going to be doing this in a terminal, we have somewhat limited, kind of options for what we're going to do. Because terminal, of course, is monospace. It's going to have, different height characteristics. You can't sort of change the line height, at least on the terminal we're going to be using. And so we have some limitations. And of course, we can't make a solid bar. Well, I suppose we could using the bar characters, but we'll do it using something else. So that's our problem today. So now let's go back to what we're doing here, problem solving. One of the steps that you can do is to break the problem down into smaller problems. And this is sort of where we're going to begin our actual coding here. So we want to first theorize kind of what this might look like. And, if we're doing something basic, I'm just going to, make comments here. So if we're creating a chart, we can imagine that if our data, let's just create some data. So imagine we wanted to chart something like 1, 2, 3, 4, and 5. What would that look like on a terminal chart? Well, it'd probably be 5, 4, 3, 2, 1, then a 0. And then down here, it'd be 1, 2, 3, 4, 5. And then for each of these areas, maybe we're using the underscore character here. So that would be so it would be, let's see, be 1, 2. Yeah, but you get the idea. So, if I do enough here, anyways, we're just mocking it up. It doesn't have to be perfect. And that's sort of the point of mocking the stuff up, is that you don't have to make it perfect. You just have to sort of get a gist on kind of what it's going to look like. So if we were going to map that data into a chart, then it would look something similar to what we see here. On the left side would be kind of the range. So we know we have a range. We know that the range on the left side is going to start at 0, and it's going to go up to the maximum value in our data. And then from there, it's just going to incrementally step in the right sort of, increments. So obviously, if our data had a 30 in here, and we had 6 steps, then it would be something like 0, 6, 12, 18, and so on. So, and these are all things we're going to have to kind of do in code. And while this may seem like a kind of simple thing, it's not. It's actually a bigger project than you might seem. But it's not so long to where, it's so complex you can't do it. We'll probably do this in, I'm gonna guess, 50 or 60 lines of code, maybe, probably less. So we'll see. But now that we have our kind of visual, thing, we can just comment that out, and then we'll just leave that there. We'll just leave that there, and then we can start kind of working on the code. So we have our, now we can break it down into kind of a couple different problems. We have our data here. Now let me just set up a couple boilerplate things. I want to give my file a hash bang here. And we'll use Python 3.7 today, but it should work on anything. I try to use the newest Python available on all streams and videos from now on. That way people don't use, whether or not Python 2 is still valid is sort of another argument, but we'll use Python 3.7 for this, but anything Python 3 should be fine. So we have our data. We want to create some data that we want to chart. So we'll create something slightly more random. We'll say like 3 and 18, 9, 24, 32, 18, 19, 7, 10, and 16. So that'll be the data that we want to actually chart. So we'll start by, now hopefully people can kind of start seeing something that you might be able to do to structure this sort of data. I know when I see a number of rows and a number of columns, I start thinking multi-dimensional list. And that's kind of the first step that I would look at, is I would say, okay, well, I know that if I have 1, 2, 3, 4, 5, 6, 7, 8, I know if I have 9 values, then I'm going to have a total of 10 columns. The first column is going to be the numbers that, will kind of tell you where the bars go, and then the next 9 will be a column for each of these values. Then I can imagine a row is just going to be some arbitrary number. It's kind of going to be up to me. I can just decide, well, do I want 3 rows, 4 rows, 5 rows? And that would be, yeah, shebang, not hashbang, sorry. And that would be the sort of, do I want 10? Do I want 3? And that's kind of up to me, because that's just kind of the height of the chart. You can take a chart and you can make it taller, and all it does is just stretch all the numbers and all the bars out. So that's going to be totally up to me. But looking at this, I'm thinking two-dimensional list. So let's start by doing that. We have our data. So we know we have a chart. Chart's going to be an empty list, but it's going to start out as an empty list, but really what it's going to be is a list of lists, and that will give us a kind of row of columns. So that'll be nice. And then we can start kind of from this point. So we can do something like for row in range, and then this is kind of where we determine how many rows we want. Do we want 5? Do we want 10, 8? But whatever we do is we want this project to allow us to possibly change this later. So we want to do it dynamically. We don't want to actually hard code values and say, well, this will only work with 3 or 4 or 5. So to start, let's just do like, I'll do like 10. So range 10. So what we got to do in this case is, remember, we're looping over every row, and the intent here is we're trying to just, remember, break it down to smaller problems. And the first problem we want to do is we want to kind of lay out the chart structure. We want to kind of look at this chart as a number of cells, a number of rows, a number of columns. And then the goal would be to basically lay in the values to this multidimensional list, and then print out those values which will represent the chart. So we'll start by making 10 rows. And then remember, in each row, we need to add a number of columns. And the number of columns that we're going to add is going to be based on whatever we have for data. So in this case, if we have 9 numbers, then we're going to end up having 10 columns. First column is going to be the values on the left. Next 9 are going to be the values that actually get put into there. So we can start by doing chart.append empty array. And the empty array is going to represent kind of one row. And then what we got to do now is we have to actually add the value that's going to be the step. And for that, we kind of have to calculate a couple things here. The data, it's going to be important to know the minimum. What is our lowest amount of data? We can do that pretty easy. Minimum equals min data. And this should give us a 3, of course. And then it's going to be necessary to have the maximum of the data. That's going to be helpful later as well. So for that, it's roughly the same thing. So this will give us, minimum will be a 3. And maximum will be a 32. And really, we're creating these values because we know we're going to need them, because we're going to have to calculate kind of what these step values are. And to do that, we're going to need at least the maximum. We're also going to need math. That's going to be helpful at some point, so we'll just add that now. I kind of want to keep my chart in view kind of a little bit here. So we've kind of added our first row, and then what we want to do now is we want to actually add the very first value on the left. So it's going to be that step value. So to do that, we can do chart. We're going to reference the row. The row will be 0, 1, 2, 3, whatever. We're just going to reference basically the row, and then we're going to append the value onto that, and that value is going to be the ceiling of the maximum divided by, and then this is going to be the number of rows. So in this case, a 10. And then we're going to multiply that by the actual row that we're doing. So this will do the maximum, which will be 32, divided by 10, multiplied by 0, 1, 2, 3, depending on the rows. Now, right off the bat, you can kind of see something that can be improved before we're even continuing in the code. We can see now that we have 2 instances of 10 here. And that's not good, because if you wanted to make this sort of thing larger or smaller, you'd have to modify both these values, and of course that's not good. So this is a good opportunity to introduce some sort of constant value that we'll call rows. Let's do 10. So now we've introduced a constant value. We can just replace both those 10s with rows, and then if we want to modify kind of the dimensions of the chart later on down the road, we just update rows, and that's kind of that. Everything else should calculate normally. You could see so far, nowhere in the code, other than the actual data, nowhere in the code have we hard-coded any values. And this will allow us to actually kind of expand and shrink this as we deem necessary. So now that we've done that one value, all we got to do now is just take the we got to look at the actual data, and then I'm trying to think what we got to do. Okay, so for each row, so we're doing each row, and then we want to lay in, basically, we want to lay in kind of a placeholder for what the bar might be. So, we know on our mockup here, we know that we're going to use, say, an underscore to mark, a point where the bar goes up to. And then if we don't have a bar, then we really just have a series of blank characters. So that's kind of what we're going to start with. Kind of our starting point is going to be blank characters. And then as we lay in the data into this chart, we will insert a underscore instead of a set of blank characters. So what we want to do kind of next right here is for, D and data. Then we want to do chart row, dot append, and then we'll just do like 3 blank characters. We'll say that if the bar does not reach that high, it'll be 3 blank characters. If the bar does reach that high, then it is a blank character, an underscore, and then a blank character. So we've kind of done some stuff here. We can kind of take a second and just run it and kind of see what our chart looks like, just to see if we're getting kind of close. I mean, it may not look like much, but I think we are on the right track because you can kind of see that we have a 0, and then a 4, and then a 7, 10, 13, 16, 20, 23, 26, 29. So those are our step values, and that does seem to be working. We have a max value here of 32, so actually it's not working. So we have a max value here of 32. It's possible that it won't actually reach that final value just because we're doing ceiling. So that might be okay. We'll leave that for right now. We'll get to the end and see if that still works out. And then now we just have 1, 2, 3, and there should be about 9 of those. So if we were to represent this as an actual chart, and I suppose we could just jump to the end and do that, then really what we'd have is numbers on the left, and then everything else would just be blank. And maybe this is a good time to just jump to the end and actually show kind of what we have in a chart and then kind of fill it in. So let's just do that. So if we wanted to just print out this chart in kind of a readable format, we could just loop over every row and then loop over every column and just output whatever's in the column. This should be fairly easy. So for this we'll need sys because we can't use print because print will give you a new line. So we have to use sys.standardout.write. And then this should be fairly simple. We can just do for row and chart, for col and row. And then in here we can do sys.standardout.write. And then we will just write the column. And then after for each row, we can write we'll do a new line. So this should give us something. So we don't need this print chart anymore. Our intent here is to actually print the chart in kind of a nicer way. Oh, it didn't work. Okay. Right must be string. No problem. I mean, that's actually pretty much right. It's just sort of backwards. Our chart's kind of upside down, and that's easy to fix. We could just reverse the list, and that would fix that. But this is what we want. It's just now what we have to do is we got to lay in these underscores. And these underscores are going to show us kind of how high the bar should go. So if the first value is like a 10, then we need to put 1, 2, 3, 4 underscores. So that's kind of the thing that we're going to try to do, now. That's kind of the second step. And we can kind of annotate this step as, chart structure. So that's it. We got the chart structure done. That's great. And then now what we need to do is go and lay in the values. So that seems like a sensible next step, lay in values. And this is where it's going to get a little more complicated because we're kind of looking at every cell and then we're determining, does this cell need to have an underscore to say that this value is that high? And to do this, we're going to first loop over every row in the chart and then loop over every column in the row. And then we're just going to compare whether the value is higher than the step value, and if it is, we're going to drop in an underscore. So we're going to do for let's see, it's going to be row in enumerate. I want to use enumerate because enumerate will give us access to the actual index value, and we're going to need that. So we'll do r idx. So that'll give us that'll give us access to the row index, and it'll also give us access to the row. Then for here, we got to do the same thing for the column. So it'll becidx col in enumerate. In this case, we need to look at the actual data though, because the data is going to be what is kind of dynamic. So we gotta look at this actual data, and that will give us access to like the 3, 18, 9, 24, and so on. And then our comparison at this point is just, is the column value greater than or equal to the very first element of that given row? And in this case, the given row is going to be, remember, our 0 value in each row is going to be the step value. And that's the one we got to compare it with. So we're looking at, we're saying, is the value higher than the step value? And if it is, then we're simply just inserting an underscore in that exact location. So we do chart, row IDX, column IDX, equals space underscore space. And keep in mind, I made some notes ahead of time for this video, but I don't have a full solution, and I didn't try to overly optimize this. I'm kind of, we're going to do an optimization kind of pass over this in the end to see if we can make this any better. But there's, there could be quicker ways to do this, and we'll see what that looks like, in the end. So in this case, let's try our code and see where we're at. Okay. So what's our problem here? For CIDX, call and enumerate data. Okay, the problem is we need to skip that first column, because the first column in the data in this case. Okay, so we need to start at 1 because we don't want to change the we don't want to change that first column. We need to sort of like push it over and start on the next one. Okay, well, this is something. This is sort of an upside down chart, but this is certainly something. I mean, it actually kind of looks like it works. It's just sort of backwards. So let's just flip this chart real quick. And we can do that very simply just by doing chart.reverse. Let's run it again. I mean, that's looking pretty snazzy so far. Of course, I don't know what well, we do know what our data is. So we know like our first thing is a 3. So a 3, it gets 1 bar because it's not quite a 4, so it doesn't get a second bar. We got an 18. So the 18 gets 1, 2, 3, 4, 5, 6 bars. It goes up to 16. So it looks like it's kind of working, but you can see everything is sort of, shifted weird, but, we could fix that. That's sort of part of the, back to my notes here. That's part of the experimenting, solving, and then refining. And that's kind of what we got to do now, but this is definitely progress. It's definitely a step in the right direction. So let's solve those problems. The next thing we should probably do is we kind of want to get the actual values, beneath the chart so you can see. Oh, Colin Paget, great, simple, and clear content. Keep it up. Thanks a lot for the $1.99. Really appreciate that. Hopefully this stream is helping you out, and hopefully it's been clear. So thank you for that. So a good next step is probably to get the data below the chart. We want to write what the actual data is. And we could do that in roughly the same way here. It's just instead of doing for row and chart, we'll just do for D and data. And then we'll just use sys.standardout.write. And then we'll write, D. That should be good for now. Let's see what that does for us. Let's actually clear this as well. Okay. Must be a string. Keep giving it an int. Okay, so yeah, it did it, not quite, but I need an actual, space here. We're getting there. We're getting there. It's getting close. And all we're doing is just refining here. We're trying to basically just line everything up now, but we're really close. We're really close to this working. So one of the problems that we should probably fix first is making these line up properly. And you could probably, Fidget, Felix Food, $2. So he got, let's see, he got transistors last week. So he will get, I think, capacitors this week. So thanks for that. Felix, thanks you for the $2 worth of capacitors. So you can see sort of on this left-hand side, and this goes back to the whole, like, we want this to be dynamic. You know, we want to be able to insert any data in here and have it work perfectly. So if we're going to have a situation where these numbers are potentially 1, 2, 3, you know, maybe 4 digits wide, then what we can do is we can use a Python function called rjust to basically make these kind of a fixed width. And so let's go ahead and do that now. So rather than just printing the actual column, what we'll do is we'll use f-strings. And then we will do string column dot rjust, and we'll do like a 3. And then we'll put a space after that. And this should fix our problem with the justification issue. And you can see it does. So now we have this nice kind of justified set of numbers here. And then we have bars that are perfectly straight. And that's because smaller numbers don't lend to smaller, you know, smaller indents. So that's kind of solved here. You know, of course, we still have this to work out. So we know there's going to be a quite large gap kind of in the beginning there. So we'll just kind of guess, you know, like standard out, dot right. We'll just write a bunch of spaces, you know, just to see if it gets it kind of closer. Okay, that's actually perfect. I was able to land the 3 exactly on that bar. So all I need to do now is just calculate, you know, what kind of justification do I need for these numbers to make it work. And I already know that each of these are 3 wide with 1 space as a gap. So that means I should be able to justify those with 4 characters, and then that should line them up perfectly. So we'll use a similar thing that we used here. We'll just copy this down here. And then instead of writing out call, we'll write out D. And then instead of rjust, we'll do ljust. And instead of a 3, we'll do a 4. And it should get us pretty close, if not spot on. Okay, not quite. So we're getting there. So you can see each of these are continuously, you know, 1 off. And that's not exactly what I want. So I'll try to set this back a little bit here. Let's see, let's dial this down to... Oh, you know what? It's the space. I forgot to remove the space. There we go. Look at that. So we're pretty much there. This is kind of it. We're actually, I think we might actually be done. I mean, does this match our use case? I suppose it does. You know, we got our step values on the left-hand side. We got our values on the bottom here, and then we have a bar that represents the actual chart. And this is kind of our visual charting thing. So, you know, I can imagine we have our solution now. You know, maybe it's kind of crude. You know, there's a couple things that we could refine here. You know, the first is that we could also make the, you know, data dynamic, for instance. So I think it'd be cool to, instead of create an array or, you know, a list of numbers, we could create a dynamic list of numbers. Oh, some guy in Sandy, really liking the Python tutorials. Thanks. Thanks a lot for the 20. I really appreciate that. That's very nice of you. And yeah, Python, I love doing these. I hope they're helping out. I know this one's on the more complex side, even though it doesn't seem it. So I hope everybody's getting some stuff out of this. And I'll make sure I post this code at the end so you guys can check it out. Or if you want to try to make it better, you know, that's cool too. So let's make a couple more changes here. The first change I want to make is I want this data to just be completely arbitrary. So we can do that fairly simply using random.randint. So rather than creating just some whatever, you know, we can say random, let's see, random.randint, and we'll give it a, you know, 0 to 99, something like that. And it shouldn't matter what number we pick, but we'll do 0 to 99, you know, for I in range. And then at this point, we're picking the length of the data. You know, how much data do we want to map? And maybe this is another opportunity for another constant. So let's actually call this columns. And instead of specifying columns there, we'll specify columns up here. And we'll do 10. So 10 rows, 10 columns. So not quite, invalid syntax. For I in range. Nice. So now actually every time we run it, we get something, we get a different chart. We could actually just turn this into a loop if we wanted to. While true, do clear and chart.py and sleep 0.3, done. So now we actually have our chart kind of animating, and we're just showing, new values kind of as we go. And we can modify this as well. Donovan, need to head out. Thanks for the stream. Okay, thanks a lot for coming. I appreciate you coming. We'll do another one in 2 weeks, so I'll definitely be here for that. And thanks for the 2. We're basically done anyway, so hopefully you got some stuff out of it. So let's actually try adjusting the number of values and then the height of it. So remember, we can adjust the height dynamically here. We can say, well, we don't want 10 rows, we want 20. Oops. So you can see now our chart's even higher. And then maybe we want it wider. So maybe we want, like, instead of 10, maybe we want 16. Well, actually, what I'm realizing is that as I adjust this, it's actually just, it's sort of adjusting it in real time. So as I modify my columns and save it, it just adjusts it. So if I want, move this back up. Yeah, and the other thing I can change too is I can change the size of the numbers. So we'll update this to like 999. You can see now we have big numbers. But in the end, it's all still working. If we just freeze one of these and test it, we can see that like 194 goes up to the right spot, 438 goes up to the right spot, and then 712 goes up to the right spot, 940, and so on. So everything is working perfectly. It's working as we expected. So let that run a little longer. And this gives us the flexibility, to do kind of whatever we want here. We can change these to whatever we want, and we could actually even abstract this 999 out to, like max int. That way we could just call this area, the configuration for our, animated dynamic, chart. That's kind of cool, right? So yeah, 41 lines of code. 41 lines of code to make a terminal chart. So I want to jump back to some questions here, and I want to also re-review the kind of the steps in our problem solving. Actually, I want to do that first. So, if we go back to our problem solving and we thought about the big picture, we said, okay, we know what the chart's going to look like. We know our limitations because we're doing the terminal, and we have a general idea on kind of how we're going to lay it out. And then, if the big picture is visual, do a sketch, and we did. It is visual. We didn't draw it, of course. If we had a whiteboard, we could have certainly drawn this out, but instead we just used Python commenting. That was good enough. We broke the problem down into smaller problems. We said, well, we have a bunch of problems here. The first problem is we need a chart structure. The second problem is we need default data in that chart before we do any calculations. Now the third problem is we need to lay the values in the chart. So those are 3 discrete problems that you can do one after another instead of trying to just over-architect the whole thing. Yeah, that would be cool. Some guy in saying it'd be interesting to chart live serial data like from a pressure sensor with this. Yeah, it'd be really cool. I mean, there's lots of opportunities to use something like this, and you could even have it, on kind of like a sliding. It could be sliding. You could do time series data, through the terminal. It'd be something interesting. So of course we did some experimentation, and the experimentation phase of what we did here was we were outputting a chart that was basically empty. But that's still part of the experiment, is you kind of want to have in your mind, am I approaching the right solution? Am I approaching my desired end state that I previously mocked up? If so, keep going. If not, then figure out what's wrong and, change some things. So finally we did the real solve. We combined all our smaller solutions together for a big solution, and then we did some refinements. We added some constants, we abstracted some of the data out, and then we looked at better ways to make things better. Things like the justifications on the step values and the justifications on the data values. And then what we ended up with is a really clean looking terminal chart that supports currently values up to 999. Now you could even keep in mind that our justification down here is a 3. but we could easily take the string length of the largest step value and just insert that instead of the 3. And then from there, it's feature proof. You could map values that are millions, big, and that'd be kind of interesting. Okay, let me take some questions. We got about 10 minutes left. We'll be doing the remainder. If you have any questions about this, you can certainly ask them now. I'll be posting my solution to this right after stream, so you'll be able to click on the link in the description for GitHub, and then you'll be able to download this. And if you want to improve it, feel free to do so. I'd be interested to see, what different things could come of this. So let's look at some questions. How would you rate Python in the scale of being easy or hard to learn? Of course, I would regard Python falls into that category of easy to learn, hard to master, because Python still has a pretty large standard library, and while the syntax is not particularly hard to learn, of course the standard library, the more vast that is, the more things you got to learn for that. So I think it is an easy to learn language. It definitely has a low barrier to entry. If it's something that you want to get into, it's definitely something worthwhile. So definitely pick it up. Does Atom provide good debugging capabilities? It does. Atom also has Atom IDE, which you can use to do attach real debuggers. I don't really use those normally. I'm more of a console.log kind of guy, for debugging, but they do exist. Debugging capabilities do exist with Atom. Dulaha asked, what's the difference between an array and a list? They are exactly the same. It's just Python's terminology calls it a list, whereas C and JavaScript and most other languages call it an array. So you can think of them as the same. It's just different terminology. Sorry when it messes up. Kasutra. Yeah, sorry, I'm not gonna try it. What does the first line do? I see it a lot in code files. So basically what this first line does is it says if this file is marked as executable, what should it use to execute it? So in Linux, you'll notice what I did here is I didn't do Python 3 chart.py. I did /chart.py. And basically what that says is it says, all right, well, this is an executable file. So what it will do is it'll look at this first line and it'll say, what should I execute this with? Now, I could have just done user bin Python 3.7, but if I did that, I can't guarantee this to work anywhere. By doing user bin env, I'm basically saying take whatever Python 3.7 points to in the current environment and then execute it with that. So that's what that first line does. And this is helpful for scripts that you don't intend to actually call the interpreter with when you run them. That's all. But I could have very well just done Python 3.7 chart.py, and that would have worked too. And in that case, that would just ignore that first line. Nikki Shrek asked, so is it better to import sys and use standard out over changing the end character of the print function? Either one's fine. Print doesn't do it by default. I just feel like sys.standard out's more clear in that case, but you can also do that. That's perfectly okay. Are you still using KDE? If so, which theme do you use? I'm kind of done with GNOME. So I haven't used KDE in probably 13 years, I would say. So I currently use Xubuntu, which is Ubuntu with XFCE. I'm also not a fan of GNOME. I don't think I've ever used just straight Ubuntu with GNOME. So I completely get you there. I don't care for GNOME either. All about code, how to learn data structures and algorithms. Well, I actually have a data structures video coming, not all of them, but I'm planning on doing a hash tables video in C coming in the next 1 to 2 videos. But how to learn them, there's tons of tutorials online, there's tons of videos. Of course, I don't have any at the moment, but there's certainly tons of ways to do that. There's also some good literature out there that describes. The good thing about data structures is there's sort of a fixed way of what a data structure is. Like a hash table is the same no matter where you look. However, the implementation might be a little different, but they all have the same kind of concepts. So that means that, if you're reading up on data structures, you're at least learning kind of a core concept of that data structure. So it shouldn't be hard to learn. Why are you so handsome and smart at the same time? Well, that's I don't know. You have to thank my parents for that. No, I've been working at sort of people say, oh, you're smart, this and that, and I like to think that I've put a lot of time into this. I've put a lot of time into learning kind of these skills. I don't personally feel special or anything. I don't feel like I was born with some crazy intellect. I'm not like super smart dude. But I have put a lot of time into refining this trade. I have put a lot of time into making sure that I'm as good as I can be at this, and it's something I really, really enjoy. So when you combine those two things, what you're left with is a recipe for learning and retaining a lot of data really fast. And then, of course, I do Engineer Man. I teach people about the stuff all the time, and that helps me. I mean, people think it's a one-way street, but it's not. I'm teaching you, but I'm also refining the data for myself because I want to make sure I put out the best data for the people that watch my videos and my streams. So I don't, I make sure that I'm overly knowledgeable on what I'm putting out. So it gives me an opportunity to refine my trade as well. So it's sort of a two-way street. But thanks for that comment. I appreciate it. What are your thoughts on Go programming language? Have you used it? Thoughts. So I have used it. I actually have a project on GitHub called Dispenser D, which is it's a message queue system that was written in Go, and it's actually used in production with at least 3 projects that I know of, and it's been stable for like 3 years, so it seems to work. I like it. What I really like about Go, I think, is that it's fairly simple to write. If you consider for a second that Go will take your code and give you a binary at the end, that's pretty significant because that implies that it is doing ahead of time compilation. So when you look at syntax, it's not overly hard to write, but you get a binary at the end. That's pretty cool. So I think if you take that into account, it's kind of a good concept. I still think it's still a new language. It's still a hype language in my opinion, but I think it has huge potential. I just hope they don't ruin it with Go 2. That's all I hope. How do I go? How do I go from scrub to you? So that's kind of I sort of answered it in the context of talking about kind of why, how I got to this point. And I think the best way to go from, and nobody's a scrub, it's how do you go from no skills to a lot of skills? Well, you got to really commit to this. You got to commit to this, and you got to remind yourself that this is not an overnight thing. You're not going to sit down at 5 p.m. and then by 9 p.m. you're a master C++ programmer. That's just not going to happen. So you have to accept that it is a long road, but you must also realize that the farther down the road you get, the easier it gets. And the other thing is a lot of programming is just problem solving, as we showed today. I didn't write that much code, only 40 lines, which I could probably condense to about 32. And a lot of it was the problem solving. I had to actually think. I had to use my noggin and say, how can I make this work? Because the code's not that complex. But imagining what code you need to write, that's kind of the hard part. So, and you'll see that as time goes on, you get better at problem solving. These things come more naturally to you, and then you're able to get stuff done quicker. So, no big deal. Yeah, 20 hours of proficiency. A lot of people get this kind of mindset wrapped up in their head that, oh, I just need to write some Python, for a couple hours here and there for the next few weeks, and I'll get a $100,000 a year job, or I'll be able to do anything. I'll be able to take over the world. But that's just not the case. It really is a long, arduous road, but it's very rewarding, and it's a skill that gives you limitless possibilities to control limitless amounts of things. And if you look at that as kind of the end state, then it makes sense to spend that time. It certainly is time well spent. Okay, let's see here. Do a couple more. Got about a few minutes left, so let me make sure I got all these. Yep, okay, I'm going to answer this one. Let's go to Engineer Man. There's a dilemma. I love programming, but there are so many things I want to do, but I can't become a master at all of them. ML, mobile, web dev, physics simulations, etc. Your advice. My advice is you have to pick the area, at least in the near term. You know, when you've been doing this a decade or two, then you will be, you'll at least be highly proficient in all of those. But in the near term, and this is advice for everybody, you know, you want to pick the thing you're most interested in. So if you really like Android programming, then you need to focus on things that are going to make you a better Android developer. Things like Java, things like Android Studio proficiency, things like XML, and then of course understanding the Android APIs very closely. You know, but if you're mostly interested in web dev, then just, you know, put Java aside, put Android Studio aside, and you want to focus things on JavaScript, Node.js, HTML, and CSS. So you have to, at least in the beginning, pick the thing you're most interested in, because otherwise what you're going to end up with is you're going to be kind of a new programmer. You're going to be just okay at a lot of things, and that's not going to be a great way to kind of get you going. You really want to get a firm understanding of one thing first, and then you can build from there. Because keep in mind, syntax is fairly similar. I'm sorry, that's not what I meant. I meant like, you know, basic syntax, things that are supported one language to the next, they're all fairly similar. Like all languages support ifs. You know, all languages support loops. All languages support, you know, primitive data types. And because of that, you start seeing commonalities across all these languages, and it makes learning another one easier. So if you're a professional mobile developer, you know, going to machine learning is not going to be, you know, excluding the math piece, of course, it's not going to be super hard because you're already going to have a good understanding in one language. What's your favorite Python web framework? I have only really used two, Flask and Django, and I prefer Flask with SQL Alchemy just because I find that to be most easiest to write things in. But you know, again, it's all, a lot of it's preference. You know, the best framework, kind of like the best editor, is the one you can get the most amount of work done in quickest, you know, without leaking all of your personal data. Okay, one last question here. You said you are a self-learned software engineer. What was the best method for learning all the stuff, reading videos, etc.? So I like reading documentation, but the best possible way, and again, this is broad advice. This is advice for anybody. The best way to learn a programming language is to get out there and start and finish a small project that you believe is tougher than what your skills allow, because I mean, you can write 1,000 hello world programs, but that's not going to make you a better programmer until you're challenging yourself and pushing the boundaries of what you believe you know. You can't get any better unless you do that. So you have to find things that seem like lofty goals. And I do that too. Like recently I was looking at Flex and Yak to make a tokenizer for a possible new programming language that I was going to make. And you know, that's a super advanced topic, and one that I still think is a little higher than my skill level. But you know, that's the only way I'm going to get better, is I need to look at these really advanced topics and I need to try them out, and I need to fail, and I need to fix it, and I need to succeed. And in that process I become a better programmer. And remember, everything just scales. You know, that's what I'm doing at my scale. But at a beginner scale, the same thing applies. You know, pick a mid-level project that exceeds your beginner skills. You know, and then pick a senior level project that exceeds your mid-level skills, and then so on and so forth. Because the thing about technology and projects and what we're doing here is that there's infinitely hard things, you know, in technology, and technology continues to grow. More things continue to come out, and never in your life should you ever be at a point where you say, well, I know everything, I'm great at everything, there's nothing more to do. That's just not the case. Technology is too vast and too broad for that to ever be true. So that's the best thing I can say for that. Okay, I'm going to do just one more question. I'm just going to look through the chat, pick something random here. And then that'll be it. One last thing. Let's see. Actually, my team did a really good job of putting all the questions in Discord for me, so I don't actually think I missed any. I really want to do one more. Just one more. Let's see. Actually, I didn't miss any here. Okay, this will be my last one. So Shreyan asked, Engineer Man, how do you apply data structures and algorithms in real-world application development? So oftentimes, the reason data structures exist to begin with is for two reasons. One, it's to structure the data in kind of a logical way. But the second thing is generally when you're using data structures, it's to both improve the rate at which you can process data as well as have predictable kind of time complexity. So, you know with a hash map, for instance, that you're going to get O1 lookups because you're just kind of hashing the value and just seeing if something exists in that spot. And if it does, you take the value and that's sort of the end of it. But if you were not using, say, a hash map data structure, you would end up with like, so if you have a 10,000 item hash map versus a 10,000 item list, which you're just seeking through to find a key, that would be extremely slow. That'd be really bad time complexity. So the way you apply them kind of in the real world is you got to look at what are your data challenges. What are the problems with the way you're storing the data? And you may be storing such little data that it doesn't warrant using some crazy data structure. But things that process a lot of data, things like databases, things like systems that are ingesting tons of data, and they need to get this in a format to which they can look things up or search through or do various operations on. It becomes essential to structure that data using the proper thing. So I guess a quick answer to your question would be you should look at your use case, you should look at how you intend to use your data, and then you should structure it accordingly, according to the most efficient data structure relative to your problem. Okay, so that's it for the stream. I just want to say a couple thanks to a lot of people. Thanks to all the people who support this channel monetarily and support this stream monetarily. I really appreciate it. That's very nice of you. Also, if we do have a special role on Discord, if you don't have the supporter role and you made a donation today, certainly let me know or one of the staff know that you would like that role, and we can certainly add you. That's no problem. And then I will post a link to our Discord here. We do have a Discord server. It's discord.gg/engineerman. The link is there. And we got like 5,600 people on there now, I think, with maybe 800 or 900 being active at any given time. So it's quite a large community. It's very well curated. You're not going to find any nonsense there. All you're going to find is lots of people who are passionate about their trade and who are willing to kind of share their knowledge, myself included. I'm always on there as well. So we have a great staff there, and you should certainly check it out if you haven't done so. So if you're a first-time stream watcher, we do these streams every other Saturday, unless there's some extenuating circumstance that doesn't allow me to do so. So we'll be doing another one here in 2 weeks from now. Two Saturdays from now at normal time, noon Central Standard Time, 5 p.m. GMT. And other than that, I'll be posting this stream will go into YouTube after this, so if you missed it, you can certainly watch it again. And the code in the description will become active here in about 10 minutes after the stream. And then other than that, be on the lookout for all the new content coming. Be on the lookout for the 250K video, which I really am determined to finish it. I'm going to. I just don't know when. So I apologize for that. And other than that, hope everybody has a fantastic rest of your weekend, and I hope to see you around on another stream or on the server or on a video. Other than that, have a fantastic rest of your weekend and take care.